These two candles are identical, same open, high, low, close, and volume. But one came from a calm staircase of trades, the other came from a violent drop and recovery. The candle looks innocent because it has forgotten the path. And at the end, I'll show you how one false tick can move not one candle, but every tick bar that comes after it. Tick data is the event stream before that compression. One tick can be a trade, a quote update, or an order book event. For the trade bars in this video, we count only accepted trade records after the feed policy is applied. And no, a tick does not automatically mean one price change or one share. A 10 share trade and a 10,000 share trade can each count as one tick. A bar takes many eligible trades and summarizes them. The first trade becomes open, the maximum price becomes high, the minimum becomes low, the last becomes close, and quantities are summed into volume. That makes charts fast and analysis manageable. It also destroys detail. OHLCV is market data compression, except the unzip button was never shipped. Time bars let the clock decide membership. For a 1 minute bar, trades from 9:30 up to, but not including, 9:31 belong together. A trade at 9:30 and 59.999 seconds stays in the first bar. A trade at exactly 9:31 starts the next. Duration is fixed. Trade count and volume are not. If nothing trades during a minute, you must declare whether that interval is omitted, filled, or represented another way. Tick bars replace the clock with a counter. A 3 tick bar closes after exactly 3 eligible trade records. The same 3 trades might arrive in half a second during the open or take several minutes during a quiet period. Trade count is fixed. Duration, volume, and notional remain variable. The counter is extremely democratic. One tiny trade and one giant trade both get exactly 1 vote. Now feed the same 7 trades into both machines. The 1 minute clock groups trades by wall time, leaves an empty 9:32 interval, and places later trades in 9:33. The 3 tick counter ignores those minute boundaries. Trades 1 through 3 form bar 1, 4 through 6 form bar 2, and trade 7 becomes a partial tail. Same tape, different sampling clock, different candles. Neither is the raw tape. What survives in a bar? Open, high, low, close, volume, interval, or closure metadata, and if you design it properly, first and last trade identifiers. What disappears from plain OHLCV? Exact event order, the intra-bar path, venue details, sale conditions, and the ability to know which event happened between the high and the close. Two wildly different stories can therefore produce the same candle. Time and tick are only two clocks. Volume bars close when eligible quantity reaches a target. Dollar bars close when recorded price times quantity reaches a notional target. Other activity-driven methods use directional activity or persistence. More sophisticated does not mean more truthful. Choose the clock whose invariant matches the question you are asking. Before any bar exists, the tape needs a constitution. Resolve duplicates, cancels, and corrections. Declare which sale conditions and odd lots are eligible. Preserve sequence order when timestamps tie. Keep sessions separate. A raw feed is not automatically clean truth. It is more like a group chat where some messages arrive twice. One gets edited and another says, "Sorry, wrong trade." And name the clock precisely. Event time, exchange publication time, provider receipt time, and your local ingestion time are different facts. Build membership from the declared timestamp, but preserve the others for latency, availability, and replay. Otherwise, your backtest may know something before your live system could have known it. On the FinTech Builder, open the time bars page first. Highlight the interval comes before OHLCV, the left closed time boundary, and the playground where changing the interval recomputes membership. Then open tick bars. Highlight what counts as one tick, the exact target ticks contract, the 3 trade worked example, and the failure table. Finish on the TypeScript and Python implementations. The site is not just showing a candle, it exposes the rules that created it. So which data should you use? Raw ticks for microstructure, execution analysis, order reconstruction, and any question that needs sequence. Time bars for time-aligned charts, cross-asset joins, and scheduled reporting. Tick bars for activity-based sampling when equal accepted record count matters. Keep the source tape and lineage whenever you may need to rebuild. Now the promised kicker. Suppose a duplicate trade was accidentally counted in a 3-tick stream. Your bars are 1, 2, 3, 4, 5, 6, then 7. Remove that false event, and the boundaries become 1, 3, 4, then 5, 6, 7. Every later membership shifts. With time bars, the clock still anchors the buckets. With tick bars, one corrected record can rewrite the downstream segmentation. That is why eligibility and lineage are part of the algorithm, not cleanup trivia. Tick data is the event stream. A tick bar is one lossy aggregation of accepted trades. Before choosing a candle, ask what must stay fixed: time, trade count, volume, or value. Continue on the fintech builder with time bars, tick bars, volume bars, and dollar bars. Which clock should close your next bar? Keep the tape, declare the clock, and preserve the lineage. Continue with the complete bar construction learning path at thefintechbuilder.com.